Hey everyone, today we're going to be doing 4.4, looking at the slope of a line and how to calculate it. When we talk about slope of a line, we're talking about the steepness of the line. So there's four ways that this can happen. We can either have a negative slope, a positive slope, a zero slope, or an undefined. So let's look at what each of those look like. So I like to think about this in terms of if I'm walking on the line. So I want you to imagine you're outside and you're walking. So a negative slope would go down. So if you were out walking, here's you, you're kind of like facing downwards. You're walking in a downward direction. A positive line, well, that would be if you were walking upward. A zero line would be if you were walking on a flat surface. And finally, an undefined line would be if you're standing on a cliff, if you will, and you're looking down and you can't see the bottom because it's undefined. So those are the four possibilities. So we have negative, you're walking downward. Positive, you're walking up. Zero, you're on a flat surface. And undefined, standing on a cliff. So let's look at an example. We're asked to plot the points and draw a line through them, and then identify what kind of slope we have. So we have the point 0, 0. So that means we start at the origin and we don't move up or down, or left or right. We're just right at the origin. For the point negative 1, 2, start at the origin, we go left 1, and we go down 1, 2. And then we can draw a line through those. Now again, imagine you're standing on this line, you're walking, you're here, we're walking forward. Are you going up or down? Well, you're walking up, so that tells us we have a positive slope. Go ahead and do part B on your own, see if you can do it, and come back and we'll do it together. Okay, so we're given the point negative 2, 2. So we start at the origin, we go left 1, 2, and we go up 1, 2. So we're here. For the second point, negative 2, 4, we go left 2, 1, 2, and we go up 1, 2, 3, 4. And we can draw a line through these guys. Now again, imagine you're standing here. Now you're standing on a cliff, so what does that mean our slope is? It's undefined. So now we're going to look at how to find the actual value of our slope. So we can look at an equation. We have our slope equation. So if we're given 2 points, x1, y1, and x2, y2, we can find the slope between the points using the equation y2 minus y1 over x2 minus x1. So in other words, this y2 minus y1, well, that is our change in y. So we're taking our two y coordinates and we're subtracting them. So this is our change in y. In other words, we can call this our rise. So here's our y1. So here's our y2, starting here. And we're going to our y1. So this is our rise. When we're looking at the difference between our x-coordinates, we're looking at the run. So we call this over run. So that's the change in our x-coordinates. So let's look at an example of how we can actually use that equation. We're asked to find the slope of the line passing through the given points. For part A, we're given the points negative 1, 2, and 3, 2. So what we'll want to do is label our points. This will be x1, y1, and this will be x2, y2, since this is our first point, and this is our second point. Using our equation, our slope, m, is going to be y2, which is right here, it's 2, minus y1, which is also 2, over x2, which is 3, minus x1, which is negative 1. So remember, since we have a negative 1, we plug that in for x, but we also are subtracting it. So minus negative 1. So on the top we have 2 minus 2, which is 0. And on the bottom we have 3 minus negative 1. Remember, 2 negatives makes a positive. So we have 3 plus 1. So our slope is going to be 0 over 4. But 0 over anything is just 0. So this tells us we have a slope of 0. And if we were to think about that graphically, remember, this means that we're walking along a flat surface. So maybe our line looks something like this. We're walking along a flat surface. Alright, see if you can do part B on your own. So we have 0, 0, and 3, negative 3. So we'll have x1, y1. Go ahead and label these. x2, y2. So our slope is going to be, the top is going to be y2, which is negative 3, minus y1, which is 0, all over x2, which is 3, minus x1, which is 0. So on the top we have negative 3 minus 0. Anything minus 0 is just that thing, so it's negative 3 over 3 minus 0, which is just 3. And then we have negative 3 divided by 3, which gives us negative 1. So our slope is negative 1. And since negative 1 is negative, if we were to think about this graphically, our slope might look something like this. Think of yourself walking on this line. It's negative, so we're going down. Next, we're asked to find the value of y so that the line passing through the points negative 2, 1, and 4y has a slope of 2/3. So let's remember our slope equation. Remember, it's our slope m is equal to y2 minus y1 over x2 minus x1. So let's label our points that we're given. Negative 2, 1, this will be x1, y1. And we're given 4y. So we don't know what y is, but that's okay. We're still going to label this x2, y2. Well, it tells us we have a slope of 2/3. So our slope can be represented by m. So we can say our m is 2/3. So now what we'll do is we'll plug in all our knowns. We know our slope, we know our x1, y1, and x2. The only thing we don't know is our y2. So let's plug in everything we know. We know m is 2/3, so we'll write 2/3 is equal to y2, which we don't know, so we'll just leave as y, minus y1, which is just 1, over x2, which is 4, minus x1, which is negative 2. So let's do a little bit of simplifying. We still have 2/3 on the left. We don't know what y is. We're going to figure that out. On the bottom, we have 4 minus negative 2. 2 negatives make a positive, so we have 4 plus 2. So we have 2/3 is equal to y minus 1 over 4 plus 2, which is 6. Now we have to solve for y. Maybe that's looking a little daunting right now, but that's okay. We can do this. Remember, when we have two fractions on both sides of the equal sign, what we can do is cross multiply. So cross multiply is where we take our numerator on the left, so 2, and we multiply by the denominator on the right, so 6. So 2 times 6 is 12. It's equal to, and then we'll do the same thing with our remaining sides. So we have y1 times 3, and we'll multiply those guys. We have y minus 1 times 3. Using the distributive property, we have to multiply 3 to y and to negative 1. So we have 12 is y times 3, which would just be 3y, and then negative 1 times 3, which would be negative 3. I'm going to bring all this up here. So we're here. Now we just have to solve for y using inverse operations that we learned from chapter 3. So we have 3y minus 3. Inverse operation tells us that we have to do the opposite of subtracting 3, which would be adding 3. So we have 12 plus 3 is 15. We still have 3y on the right. And now we have 3 times y, so we just have to divide by 3. 15 divided by 3 is 5. So our y value would have been 5. So in other words, this second coordinate point would have been 4, 5, to give us a slope of 2/3. Alright, and that's it for slope of a line. Next we're going to be looking at how to use what we learned today to create equations using slope-intercept form.